And now, without any further delay, let's begin today's event, sponsored by ClearDATA and hosted by HealthDataManagement. I'd like to introduce your moderator for today, and that is Eric Kavanagh. And with that, Eric, you have the floor.
Ladies and gentlemen, hello and welcome back once again. Thanks so much for your time today. My name is Eric Kavanagh. I will be your moderator for today's web seminar entitled 5 Reasons Hospital CIOs Are Extending Their Data Center into the Public Cloud. Yes, indeed. So a few quick opening slides, and we'll get off to the races. There's a slide about yours truly and enough about me. You can hit me up on Twitter at Eric_Kavanagh or email me, dmradio@sourcemedia.com. We're going to be hearing from Dez Blanchfield, a good friend of mine. He is the data scientist for the Bloor group, a real expert in cloud. He's been focused on this stuff for decades, yes, literally decades. He's been focused on enterprise computing and, of course, the last decade or more, specifically on cloud and understanding the challenges of cloud computing, which are certainly similar but also quite different in many ways from traditional on-premises environments. We're also going to hear from Scott White from ClearDATA. This guy really knows his stuff, too. I can tell you I've worked with Scott now for a couple of years, and the folks at ClearDATA really do have a very clear vision for how the cloud can help organizations really get on top of the situation these days. There's a lot of fast-moving metrics and vectors, if you will, in the world of healthcare in particular, and the folks at ClearDATA have been focused on that quite exclusively for the last 2 years. So let's just talk for a second about what is happening out there in the healthcare world. Well, it was about 10 years ago that Amazon Web Services went headlong into the cloud, and when that happened, there were a lot of enterprise IT people who, frankly, viewed it as not a very good way to go. They viewed it as not stable, not enterprise-grade, not robust enough to handle enterprise concerns, and the end result of that is that Amazon got more or less a decade head start on everybody else in the business. Well, these days, who doesn't talk about the cloud? You've got Microsoft with Azure. You've got the Oracle Cloud. Even SAP is rolling out what they're calling the HANA Cloud Platform. You've got Rackspace. There are lots of competitors. You have Google entering the game, for goodness sakes. Everybody is getting into the game of cloud. And what does that mean? Well, it means Amazon was right. This is a viable business model. The cloud is a viable place for enterprise computing. So a lot of folks got that wrong. Amazon was not in that group of people. So one of my favorite lines, of course, is no one ever plans to fail. They simply fail to plan, right? There's also a great quote by, I believe, Eisenhower, who said, I've always found that plans are useless, but planning is indispensable. And what he meant by that is in the process of planning, if you do so thoughtfully and carefully, you will work through all sorts of different contingencies. And then even though everything changes once the bell rings, at least you will have in the back of your mind or in the front of your mind what you want to do in certain situations. So reality is a fluid thing, certainly in the world of business, certainly in the world of healthcare. If you think about issues like affordable care organizations, for example, and how significantly those are going to impact the future of caregiving and of running hospitals, for example, that's a really, really big deal. So there are 5 different areas that we're going to focus on today: analytics, mobile health initiatives, disaster recovery, security and compliance, and then microservices and containers. That's at the cutting edge. And we're going to try to take a roundtable approach. So, like I say, sometimes people fail to plan. Well, you on our audience here today are not in that category because obviously you're paying attention. So with that, I'm going to push Dez's first slide. Dez, some comments from you, and then we'll get some comments from Scott and have a discussion on each of these topics. So, Dez, take it away. Why cloud?
Thank you, Eric. Thanks for having me today. So let's just quickly touch on what we actually mean in cloud just for 1 second. I mean, I have this line that I use when we talk about cloud because often people think it's this magical kitten with butterfly wings and fairy-colored rainbow feet. Cloud just means other people's computers at the end of the day. And we've been through this for decades in the form of outsourcing. So I think there's a lot of misconception about what cloud actually is. But really all we're doing is just outsourcing a hosted environment. We're relinquishing the need and the control to buy routers and switches and servers and storage and compute ourselves, and we're consuming it as a service in the same way that we would if we went to a tap and turned it on and filled a glass of water and took a drink. We're only paying for the amount of water that comes out of the tap at the time we turn it on demand. So Hospital CIOs and CIOs in health in general are, for the greater part, no different than any other CIO. They're tackling a series of core challenges across the organization from an enterprise point of view. Now, there are obviously some very unique requirements they have in health, and particularly hospitals and the functioning of hospitals, because they're a fairly unique business in themselves. But the actual core challenge of, and I've just captured a couple of them here, which are costs, agility, time to market, security, and scale. These are things that all CIOs are facing, but more than anyone else in the world, hospital CIOs are facing them because there's some significant changes around their world, particularly with health. So cost, that's a bit of a no-brainer. Agility, we think we know what that actually means, but in health and particularly in hospitals, that generally means that there are significant changes in the platforms and the technologies that are being brought into the environment in the hospital. So different types of sensors, different types of security, new software platforms, new devices. And so the challenge in a hospital environment is very unique in that it's significant changes in wholesale form across the type of organization you're running. Time to value. So when you think about what's happening in a hospital, the concept of time to value, how quickly you can get to the point where you go from zero to hero, as I call it, and actually getting value out of an initiative or a transformation or some form of change, this can save lives. So this is extremely important in a hospital environment for a CIO, because the business is saying, until you change this, we can't reduce this risk profile. And so this is a really big win for CIOs and hospitals to be able to move to the cloud and leverage faster time to value. Security, a bit of a no-brainer, but we're talking about, again, not just people's lives, but people's personally identifiable information at that most critical time, either when you're selectively or otherwise not deliberately looking to gain some health support. So security is a bit of a no-brainer, but again, it's a very important one that's unique to CIOs in hospitals because of the type of data they handle and the way they receive data in and out of the organization. And scale. I think the challenge around scale is ever more important in health and particularly hospitals. Again, around the technology changes we're seeing, the digital transformation, as it were. So they're the key topics that all CIOs are facing, but they're ever more present for folk in health.
Okay, and maybe, Scott, some thoughts from you on Dez's overview of why cloud. Does that all make sense to you?
It does. Absolutely it does. And I can add some comments really specifically related to the healthcare aspects. But you having been in healthcare for 25 years and been a healthcare CIO and IT leader, I've just never seen the pace of change and the scope of change this big. So healthcare has tremendous pressures and opportunities. We see this movement towards value-based care and population health and these economic pressures that are causing hospitals, certainly, physician groups, but even payers and other people in the ecosystems like pharmaceutical companies and medical device companies are having to rethink their products and their services and how do they not just deliver a device or deliver a fee-for-service activity, but how do they help people get healthier and stay healthier. So huge difference there economically. And then clinically, lots and lots of pressures with diseases that are stressing our system in new ways. And then, thankfully, new science of genomics and services that are coming to bear and medical devices that provide wonderful breakthroughs in health, but are also very information intensive. So you put that all into the blender, and it is a very, very exciting time, but a very, very challenging time. And the cloud, the agility and the cost advantages that the cloud has are one of the great tools, I think, to apply to this very challenging time.
Yeah, and I'll throw in a couple quick thoughts here. One of the really nice things that I just absolutely love about the cloud is the collaborative nature of what it enables. Because now in a cloud-based environment, as long as you have permission to be in a particular document, for example, or in a particular system, you can all work on the same document in the same virtual space no matter where you are. So you can be all over creation. So the cloud really is this tremendous marshaling area. And Dez, I know that's a big thing for you too, right? Just working collaboratively in real time in this case, for patient care, that's a big deal, right?
Well, it's one of the biggest changes, in fact, and I think if we just think back 3 or 4 years of how we might collaborate, we might do a conference call that's exciting. We may have gotten access to video conferencing, and we can wave at each other across time zones and countries and global borders. And we started to be fooled into this idea that collaboration meant joint phone calls and discussions as we're having now. When in reality, collaboration was what we've been doing for a long time in person, working together in groups and being able to interact. And so when applications and software, and particularly web-enabled interfaces, brought about this ability to collaborate online, we set up and paid attention and realized, we haven't really been collaborating to the full extent of what's possible with technology. So now we take it for granted that in platforms like Office 365 and Google Docs online with a web browser, with no barrier to entry, we can get online and work in the same document and cut and paste images. And it's a completely different approach to collaboration. It's a paradigm shift, if you like. And so when we bring that into the types of things that CIOs can provide now in applications and tools in a hospital environment, it's a complete foundational shift in the way that people work, because I don't have to be in the room with you to be collaborating on a situation if we're doing an inquiry with a current patient. If we're doing historical reviews of operational data, we can do that online. It's a massive shift in how we work together. And so that collaboration becomes a very powerful tool now that we thought we had right, but we really didn't. Now the tools are available there to collaborate properly online. Things are getting done faster. They're more fun to do. And there's some really fun things that come out of that as well in just the social aspect, where there's sort of feedback loops that are either real time or slightly delayed with likes and comments and so forth online.
Yeah, and Scott, collaboration, I think that's a big issue for you too, right?
Absolutely. Again, as a user of the cloud, I found that it was a terrific advantage for collaboration. And again, there are market drivers. Specifically, we see that now you have payers and hospital systems are needing to collaborate, as opposed to always sort of arm wrestling over things, or hospitals and independent physicians need to collaborate. And sometimes all three of those entities, and even a crosstown rival hospital, might be collaborating in, let's say, an accountable care organization where they have, for that particular project, they have common interest and they want to collaborate. Well, typically they are not going to want to send their data and have it all held by one hospital's data center. There's an advantage to putting in the cloud a sort of Switzerland for data that can be secure, but also a ripe environment to scale up in an agile way and to provide sharing of clinical data, outcomes, care measures, and things like that, so that we can drive out cost and have excellent visibility into the quality. And the cloud is really a great setting for that, and I've used it myself. I'm talking with CIOs over the country. They're seeing this issue of collaboration as being a driver for cloud adoption.
Yeah, that's really good stuff. And obviously, if there's any one industry where collaboration makes a whole mountain of sense, it is the healthcare industry, since we're trying to care for people. We're trying to care for people's health. All right, let's keep moving right along here. So analytics, where to begin? From my perspective, this is one of the hottest areas for HIT these days, healthcare information technology. Dez, what's your take on the overarching value of analytics for healthcare?
There's been an explosion in capability and what we refer to as analytics. I think historically, if we think about what analytics has meant, it's often been fundamental business intelligence. What we're seeing now is a transition to some very key verticals where analytics are not only looked at in a different way as far as how we're applying different types of analytical work on data we've got and systems and performance, but also the types of tools that are coming. So, for example, I've just noted here some key segments that I come across on a regular basis, and that is that, where we would normally just talk about business intelligence, now we've got historical analytics, streaming analytics, predictive analytics. We've got the ability to build models to apply across those different types of analytical platforms. We can do these amazing things like burst out into public clouds from current legacy systems through various tools to use cloud infrastructure on demand. In other words, if I've got a monthly report to run, I might run it overnight on a historical system, whether it's a traditional HR or ERP or finance or payroll system of some form. Now I'm looking at movement inside the hospital, and I'm looking at management and usage of assets and location of assets. I could run a report in real time to do that and see in a dashboard. If I don't have the compute to run it, and it normally takes an overnight batch job, modern tools and dashboards allow me today to build those models and perform those analytics in real time by just acquiring on demand utility computing style public cloud infrastructure. So instead of maybe saying my 4 or 5 servers in the back room, I can now just say, you know what, I've got an account on a third-party cloud, and just push that workload, including the component of data that's required securely, out of the cloud and run that report in real time. And if 4 servers take an overnight process to do it, and I need 400 servers for 20 minutes to do it in 20 minutes, I'll do that. If I'm willing to do it with my credit card in 60 seconds and pay for that service, I can do that as well. And the other big shift we're seeing now around the consumption of analytics is real-time dashboards. And you'll see in the image there, I've deliberately put a picture of someone holding onto a tablet computer, be it whatever brand it might be, because most of these tools are now browser-based. So I can walk around, I can be either on-premise or I can be working remotely. I could be at home for all I care. And as long as they've got access to the right tool through a browser interface on a laptop, in this case a mobile tablet of some form, or even a smartphone, I can start consuming and interacting with those analytics in real time and start actually getting real-time outcomes. So the whole topic of analytics has shifted dramatically from what traditionally, as I said, was just business intelligence. Nowadays, we think about analytics in a completely different way, and it gives us a lot of those benefits we talked about in the first slide around why we're going to cloud in the first place.
Yeah, that's a really good point. And Scott, the other thing that's jumping into my head here is this whole conundrum around reinventing the wheel. Well, once you start collaborating in the cloud, once you start using the cloud as your marshaling area for analytics, for example, to me, that's really going to mitigate let's call it a conundrum of reinventing the wheel. What do you think?
Right, yeah. I mean, some of that involves a degree of experimentation. Some of these analytics, you walk into the problem and you don't know the answer. That's why you want to use the data. And for some of these projects, that means that as a CIO or a CFO, you don't necessarily want to put out this huge capital expense for compute and storage when you're not really certain how this project is going to grow and be used and what the fruit of it will be. And the cloud is just perfect for that type of experimentation. It is quick and easier to get set up and then start to provide some value and experiment. And then, if you run into a dead end, and you can back up and take it a different direction without those huge upfront investments. So we're seeing, specific use cases, again, particularly on analytics, a lot of work on population health and value-based care and getting feeds of data from multiple sources, from ambulatory EMRs and acute care EMRs, and sometimes patient input data, and then looking as physicians, for instance, are caring for a whole panel of patients. How are they doing on their hemoglobin A1Cs, and are they getting their mammograms, and are they involved in smoking cessation programs, and then even drilling down, do we understand the length of stay by DRG or admission rates for certain populations, and looking for where is the variability? Is the variability in the outcomes related to a specific physician or physician group? Is it related to a hospital? Is it more a characteristic of a patient population? And then, as you understand that, can use those analytics real time, as described, to understand the causes then. And again, with this effort of trying to provide higher quality care and better outcome, and then demonstrate it's not just you saying that it's better, but you've got the data to back it up. And there's some great clinical examples as well, acute care examples where you have issues like sepsis that are very, very complex but very deadly in the hospital. And can you use analytics to get massive amounts of data from device telemetry and lab values and vital signs and things like that, and then use some predictive modeling to try to anticipate when a patient may be at risk for sepsis, and then intervene early in order to save lives. So the analytics on the cloud are very, very powerful.
Yeah, and Dez, you touched on a number of different key issues here on this slide, and one of them is this whole concept of bursting into the cloud and leveraging cloud infrastructure to do some heavy-duty number crunching. And I think that's one of the most prominent examples of why cloud is so much different and enables so much more agility than on-premise environments, because to do something on premises where you're doing heavy-duty number crunching, like around genomic analysis, for example, you need to buy a lot of hardware, and then you obviously have to use that hardware, put it to use, maintain it, get the software on it, et cetera, et cetera. Whereas if you can just burst into the cloud to crunch all those numbers and get yourself an answer, you don't have to go buy all that stuff. You don't have to take on the risk of all that infrastructure. You just use what you need when you need it for a period of time and then move on, right?
Correct, and I think almost every software manufacturer, in fact, I don't think it, I know it, every major software manufacturer, any platform builder, any brand you can imagine, is already sitting up and paying attention to what this actually means, because traditionally we would think about building software from a point of the limitation of the infrastructure you have, the amount of compute and memory and storage and the type of network you've got and the number of servers you have. These days, that when you think about designing tools, particularly in analytics now, particularly these dashboards you walk around with your hands, it isn't the case that the compute that you're applying to analytics is limited to the smartphone or the mobile device you're walking around with. It isn't the case that it's limited to the services in your client's data center anymore. It's actually limited to the number of clouds that you've got access to. And when we talk about cloud, we have till recently often spoken about cloud as this one big thing, as if it's the same fundamental element. But now we're seeing the consumption of cloud get segmented even more, in a specialized form, and that is that we've got the general public cloud where we can put virtual machines in our applications, but we also know clouds that have specific purposes for them. So, high-performance computing, some of the cloud providers are providing GPUs, so we can do not just general CPU workloads, but we can actually do heavy math and analytics workloads. So now software is morphing on a daily basis to sit up and pay attention and say, what, not only can I burst into the cloud and I can get on-demand capacity, including compute, but I can get specific with regard to the types of workloads. So if I'm running a fairly legacy-style application, yes, I can burst it out and I can compress time by just throwing more effort at it. But I might have some form of mathematical analytic tool that's built specifically for GPUs, and I can on-demand acquire cloud infrastructure with GPUs attached to it. This is a fairly significant change in the way we approach problem solving, in my view.
Yeah, Scott, and as Dez pointed out here, there are lots of different applications for analytics, and I think you'd probably agree that it's one area where you guys are probably getting a lot of attention as well, a lot of traction with customers. Can you speak to the trends that you're seeing in terms of what kind of analytics seem to be most popular with hospital CIOs?
So, I mentioned the population health, value-based care. So that's a combination of financial metrics, cost metrics, and then clinical metrics. And absolutely, I, again, as a user, used the cloud for that very workload, and that particular workload is still running on the cloud today. I mentioned the clinical examples of sepsis and complex care delivery topics. Dez, I think, hit on some other really a great trend. Some of the early adopters of the cloud were not hospitals or care delivery folks, but they were pharma, life sciences, because just as Dez described, they had very complex compute requirements, high-performance computing, GPU, massive amounts of data, and they also wanted to be able to take advantage of the economics of the cloud, where you can time slice. You can have it as a utility. So you could use this supercomputer for a few hours or a few days and then shut it down and not have to pay for it. So there's been a lot of demand for the cloud there and some of the early adoption there. Interestingly, though, of course, since much of that is research-oriented, it was de-identified data. Now, those types of therapies are translating. There's this translational medicine move to where those therapies are now hitting they're going from the bench to the bedside. So we're able to prescribe some of those medicines or run some of those tests in physicians' offices and in hospitals, and that's completely changing the nature of compute. In other words, sometimes these hospitals and physicians need access to that power, but the other big difference is, instead of being de-identified data, we're dealing with, your name and my name and our personal health information, is protected health information that must be secure, and it's got to abide by HIPAA and the other requirements for privacy and compliance. So big change in that area. It's not just analytics and lots of compute, but it also now has to be compliant and secure.
Yeah, that's exactly right. And I think you were tipping our hands here. Let's keep moving on. But mobile health is the next one we want to talk about. There are lots of very interesting use cases around mobile health. And Dez, I guess I'll turn it over to you to get your thoughts. And obviously, you're a bit of a mobile expert yourself. So how do you see mobile playing into the big picture here for healthcare?
One of my favorite ways to describe the transition that mHealth has brought about is that when you jump back 50 or 60 years and think about what a mainframe computer was, and it had a serial cable going to a terminal where you could only do text on, and you could only do certain types of text, and you could only type certain commands, and you have this mental picture of a big, massive piece of iron bolted to the floor, and you've got this long cable going to multiple terminals, and very restrictive controls of what can be done there. At the absolute opposite end of the universe, of the spectrum, you've got this environment where you've got an always-on device. Who turns their mobile off? Who turns their tablet computer off these days? Nobody. No training required. Everybody just intuitively knows how to use them. They've been made so simple. You don't need to carry a network anymore. So you don't need a wide area network anymore because you've got carrier networks. So accessibility for that new terminal, as I like to call it, is there, always on, no training required, and always connected. You've got other amazing features built in there that we've been trained with regard to the use of this device now, where instant feedback and social behavior that we've taken for granted in real life of talking to each other as we know now by the phone, but also in person in groups, people carry that behavior across in how they interact with mobile devices. And that's not just in fun things between me and my children or my children and their grandparent or general people online. It's directly into work-related things. We're seeing people want to bring their own device. They want to bring all of those things that they learned at home from personal use of mobile devices into work. We're seeing real-time things happening now, so I'm not having to walk along the terminal and log in. My device is always on, it's always connected, and I'm always logged in. So the security is around me. So I'm locking my terminal now. It's really just a case of my screen saver sort of kicking in and locking my device, and I swipe and I punch in my PIN or whatever, or I touch my finger for a fingerprint on the front or back of the screen, depending on the device, and it instantly logs me in. So I've now got multi-factor authentication with a PIN and a fingerprint. So, much lower barrier to entry. Almost everyone can afford some form of device if it's BYOD, and if the hospitals and the CIOs are providing them. Again, the cost of an extremely intelligent terminal is so much lower than these fixed assets sitting on a desk that are almost impossible to carry around. This whole new approach and user interface, there are millions of apps now, and we've learned through the development of those apps what the user interface and user experience should and should not be. So when we take the UI UX experience on mobility and mobile phones and smartphones and then tablets, and particularly modern large tablets, where we're effectively carrying a small computer screen around without the actual big chunky box behind it, we're carrying that across and applying those new user interfaces to old systems. So I could still have a mainframe in the background, but I just have some sort of middleware talking to the smartphone. So, for example, the majority of internet banking is still sitting on some form of, big heavy iron at the back end. But when you talk to your little smartphone, you have no idea. You're just interacting with some groovy, sexy-looking little colored icon. Almost nobody that does internet banking thinks that there's a mainframe in the background. In fact, they'd probably be horrified if they knew that. Same applies to what CIOs can do in hospitals. They don't have to worry about the big iron in the background anymore. They have to worry about what's in the cloud and the infrastructure. People are worried about this really groovy device they're carrying along, and it's becoming more and more part of their lives. Now, the other neat thing about this is that the interaction between me as a participant and a receiver of services in the hospital and somebody else as a provider of services in the hospital, the CIO's challenge now of taking me from old school offline and into terminals and trying to interact versus now mobile to mobile sort of type experiences where I come into the hospital with my device and I'm registering online in the waiting room rather than being passed a form on a clipboard and a pen, and then the information being immediately available in real time to the folk actually providing the health and measuring and monitoring and doing analytics. That's a significant shift as well. Remote health has become a real thing. Until recently, even in places like Africa, we would see these amazing projects where SMSs were used to move information about spread of viruses or disease or just some sort of health challenge and warn people out of areas. Now that mobile networks are catching up, that information can travel in real time, even in the form of a FaceTime call. And the next big shift in this is that in-vehicle communications, we've sort of brought the data center capability into vehicles, whether it's ambulances or individuals. I can register on the way into the hospital that I'm coming in with my better half and we're at the very last minute of a pregnancy and they better get ready for us and please meet us at the front door. I might be able to do slightly less urgent but more casual conversations about things. And in fact, an interesting thing I came across the other day was mobile health applied to social, where somebody, apparently some famous character, and I forget the details of it, I was just looking for it unfortunately, but someone famous had posted years of pictures on something like Instagram or Facebook or Pinterest, and a fan had been going through the pictures and noticed a change in the photos of a particular spot and highlighted it in a comment back saying, I think that might need to be checked out. And it turns out it was a melanoma. So all of these things that we're sort of covering here are just this quantum leap forward in what can be done and fundamental initiatives in how hospitals apply technology to their core business and how CIOs are extending all of that core business into the public cloud, because the majority of what we're doing on mobile devices now is cloud-related. It's running in the cloud either as existing services that traditionally were thought of as shadow IT, but now things we're bringing back in under the control of CIO, or moving old workloads into the cloud in various forms, and particularly analytics.
Yeah, Scott, comments from you?
Yeah, definitely see mobile health as a very significant trend for care delivery, but also for cloud demand. So the cloud provides, as Dez described, scalability. We have the ability to vertically and horizontally scale the infrastructure that you're using. In fact, and some of that can be done automatically depending on the demand. So very, very powerful advantage of bringing the cloud. There's also this demand for geographic scalability. You using your own data center, it's typically in one or two locations. Very hard for a hospital system to set up data centers that span regions across the globe in order for mobile users or others to have access to data. So big advantage of bringing the cloud to bear for mobile health. I also see the lines blurring. I think we all probably do. Many applications are now being developed mobile first. So where in the past there was this distinction between, this is a mobile application and this is a desktop application. A lot of folks, and some on the call here, may use their mobile device, whether that's a smartphone or a tablet, more frequently than they actually use the desktop. So the lines are really blurring there. We see demand in healthcare specifically for consumer and patient portals. We do support for ambulance and emergency medicine services, physician remote access, even like taking traditional paging systems and updating those and powering those with the cloud. And then as bandwidth and quality of mobile networks have advanced, we see very advanced initiatives like remote access to prenatal monitoring of waveforms for OBGYNs. And who could imagine that you could have an OBGYN that's outside of a hospital able to actually see how a mother and baby are doing real time and then give directive for interventions if needed. Great, wonderful, life-saving technologies that are now powered by the cloud.
Yeah, that's all good stuff, and I know we want to get through a bunch of more material, so let's keep moving on through. We never like to think about disaster recovery because it's such an unpleasant reality, but the fact is someone needs to focus on this stuff. Dez, what are your thoughts around cloud for DR?
Cloud for DR is a godsend in my mind, and I've had many CIOs argue till they're blue in the face about this topic. And so I tend to just pick up a whiteboard and perform some basic Jedi mind tricks with a whiteboard marker for 5 minutes and they get it. When we think about disaster recovery, what do we actually mean? Well, we mean the ability to recover from some fundamental issue that's impacted us, whether it's human error or whether it's, quote unquote, an act of God, as insurance companies tend to call it. And I've had entire data centers, in my experience in the last 30 years, where something as simple as an electrician drilling a hole in a wall to put a cable through happened to hit some metal filings, and they fell into a power distribution unit and short-circuited and took 5 stories of a data center out, and everybody was off, and took hours to fix. And who could have predicted that? So when we think about what disaster recovery means, it means a few basic things, and I've outlined some of my key thoughts here just for discussion. We often think about disaster recovery from an active copy of our environment to a passive copy. That is, we might have a production version of our world running the services in different forms, and they don't have to be all or nothing, but just parts or all thereof. So one part running live, one part sitting there as a copy of the live, but passively waiting for something to go bang. We often also approach it from an active-active, and this brings a lot of really neat features around if our infrastructure and applications and systems and databases are designed to do that, because instead of maybe on the left-hand side, part A running actively and a full copy replicated in part B on the right, just waiting there for something to go bang, if we've got the ability to do active-active, now we get both of our environments running and we get all the workload split between the two of them potentially. And if we have something go wrong, we might only lose 50% of our capacity, but we engineer so that 50% of our capacity still carries the core business forward. We also think about it from regions and zones. So, for example, I might geographically have a concern, and certainly in Asia-Pacific, in my world, in Australia, not so much Australia, but certainly Asia-Pacific, we think about things like earthquakes and tectonic plate movements. Some parts of the world don't ever think about that, but we think about it all the time because the part of the world we're in is shifting regularly, and I know in North America that's an issue as well, and certainly storms and cyclones and tsunamis and things like that. So maybe I have a data center on one, the east coast of the U.S., and I have one on the west coast of the U.S., so that if something happens on either side of the nation, I'm still okay. We think about disaster recovery from a slightly different point of view in that we might have multiple zones with an active-passive, and we use the backup copy for dev, test, and integration. So that's not a lazy asset just doing nothing. We're actually using it to have a copy ready to recover from a disaster with a plan that we kick into play if we have something go wrong. But during that downtime, while the passive environment or the backup or DR environment's not used, we might use it for dev, test, and integration. We also have scenarios where production and DR break into more of a distributed fashion. So we might have a production environment and go N+1 and run them in active passive, but we also might use it as a distributed model. So we might have multiple copies around the world, and we might push the availability out to the edge of the network and use that in various forms. In the cloud world, we talk about it in a very different way. In disaster recovery, we do everything from tape backups. We copy those backups across and sneak in it sometimes to the backup site where we restore the database regularly, or we do it over some form of fat pipe, moving the data around. In the cloud, we talk about it in the form of snapshots. And that's essentially just the click of a button and an automated process taking an entire digital copy of one environment and making a snapshot, almost photocopying it from point A to point B. And that can be done in seconds in some cases. And often, environments that have hundreds of terabytes of live data and databases can be snapshotted almost instantly, so you've got a second copy. And that could be your DR version, or it could be made a copy of and moved into a different IP address to be used for development and test and integration. Certainly, disaster recovery comes into play when we think about things like upgrades and patches and releases. There may be a release of a patch or an update that's critical, or just an ideal thing, or a software revision update. And we might do that in our DR environment. In the cloud, we think more along active-active, and we think about just making copies or snapshots of our environment. So if I want to take production as it is today and upgrade the version of software or environment or whatever it might be, something like a Y2K in the cloud would have just been a dream come true. We didn't have to physically build new data centers and take physical copies of data. We could have just taken a virtual snapshot. And this concept of failover in the cloud becomes a bit of a no-brainer, because we don't fail over necessarily in cloud anymore. We have this always-on mentality. That is, the cloud is always on, and the cloud has that DR capability built in. So now we look at how do we consume infrastructure as utility in the same way we do with power. One part of the power grid might take a lightning strike and lose an entire section of its actual grid network and the cable. but the power system can route around that, and I still have the lights on, I still watch TV, and the Cubs game successfully gets to fruition, and let's hope they get to the end of the World Series. So the power networks can cope with that, and cloud networks and infrastructure can cope with that. And so it changes the way we think about DR, because now we're not thinking about this failover, and we're not thinking about active-passive. We're thinking about active-active. We're thinking about regions versus zones. We're thinking about integrating dev test and integration through snapshots. We're thinking about distributed N+1. And more importantly, we're thinking about always on.
Yeah, good point. Scott, what do you think about all that?
So, yeah, I think Dez has really highlighted some of the power of the cloud, but perhaps to degrees some of the complexity of this topic of DR. It's there's really a continuum. There's backup and disaster recovery and archive, and you've got lots of different potential business or clinical issues that you're trying to solve and financial targets, and then you've got all these different sort of options and tools at your disposal. So I think it's important to be able to likely have somebody, to discuss the designs and the options, somebody who understands the nuances and complexities of healthcare to help you navigate some difficult decisions and really take advantage of the true power of the cloud. I've as a CIO, I've had my primary UPS go out in my data center and take it down. I've seen other just really water pipes break over my PAC storage unit and take out your image archive. And there's some really, really rough stuff that happens in healthcare. The cloud can be a part of the solution for preventing those things and then helping you recover more quickly. But with that said, I think it's good to understand the unique issues of healthcare. Things like, do you need a local cache for information? Because images and PACs are a great example of this. They're so large that you can't necessarily replicate immediately to the cloud or pull things back immediately. You need a local store. Think about speed of access to data, where some applications you may have a much longer recovery time, but other applications need to be near real time. And again, you can then architect your cloud solution to meet those requirements. You need to also think about, again, as it blends into other topics like archiving, what are your retention requirements? Again, specifically related to healthcare for clinical records for pediatric patients, you may need those to the age of majority. For most other medical records, it's 7 years. For certain specific cases like mammography, for instance, you need those for the life of the patient. And it's good to know that you're working with somebody who understands those specific complexities of healthcare.
Yeah, that's a good point, and it's actually a good segue to our next slide. And we're going a little bit long on time, so Dez, maybe just 60 seconds on each of these last four, and we'll let Scott comment on that. Security and compliance, it's a big issue. I think initially the cloud was viewed a bit hesitantly with respect to security and compliance, but these days I think the smart money is on the cloud. What do you think, Dez?
Absolutely, and just a very, very, so just for a millisecond to touch on what Scott was saying there, I think security and compliance is probably at the absolute peak of what Scott was talking about. But cloud as a concept is easy to consume, but at the end of the day, you do need that managed, and I think it's really important to absolutely nail that point home, and particularly in security and compliance. Just using the cloud for additional workload and getting that flexibility and agility doesn't remove the need to have it managed. And invariably, cloud skills, particularly when it comes to security and compliance, are even more important because there are so many nuances around how you apply regulatory compliance, internal strategic and policy and governance compliance and controls and measures. So the capability to have a partner who can manage this for you is even more important when it comes to security and compliance, because these are things that you don't tend to have yourself. And I'm going to start from the bottom of my list here, in fact, and work towards the top key point. And literally in 30 seconds, let me cover it. When we think about cloud, these are very large organizations specifically designing either bespoke or generic environments that suit different workloads. So often one of the things that people talk about is, well, when I put it out in the cloud, security an issue, how do I manage security? My answer is really simple. The majority, if not all of these big cloud providers have hundreds, if not thousands of human beings working for them, and often specifically focus on security. So for the average CIO, they might average 2 to 3 bodies that are thinking about compliance and security and risk. For the cloud providers, they have hundreds, if not thousands. And when it comes down to 3 bodies in-house versus potentially 3,000 in the cloud organization, I can guarantee you a cloud provider manages some of the fundamental infrastructure security. But where they don't help you is the things that are specific to your organization, and that's even more pertinent when it comes to hospital CIOs. And Scott was exactly on the nail there with regard to having that support to manage that. We're seeing things like data breaches come about, but the data breaches don't necessarily happen just because of the cloud. The data breaches have been happening for the last 50, 60 years since mainframes happened and people are stealing tapes. It just means that they can be done at a larger scale if you're not careful. Data sovereignty becomes a real thing when you put it into cloud. Where is my data? Some of the core frameworks don't change. I think there's the view that things change dramatically when you go to the cloud. You get a get-out-of-jail card that you don't have to behave the same way anymore. That is not the case at all. It's even more so the case. Basic frameworks like ITIL and COVID and many other common related frameworks, they are exactly the same in the cloud as they are on-premise. It's just that you have a bit more flexibility and agility. Concepts like data at rest and in motion and how you deal with that, particularly around encryption of that data and the security of that data, and certain areas where it's PCI or HIPAA or SOX and NIST compliances, these become ever more present and ever more important when you put them into an environment where you're not managing the tin, you don't know where it physically is. So the boundaries that you have controls over become a little bit grayer, and so you need to firm those up. And I'm going to throw back to Scott in a minute with regard to the thoughts around the managed piece of it, I think, because that is, in essence, the most critical piece of this. So how are you going to manage and control the security and compliance when you put it into the cloud if you don't necessarily have the skills on board?
Yeah, Scott, do you want to comment on that?
Yeah, absolutely. So if we take a step back, the cloud needs to be designed or selected with security, privacy, and compliance in mind. It needs to be built with security, privacy, and compliance in mind, and then it needs to be managed with security, privacy, and compliance in mind. So starting at the beginning, as you select, you're going to want to look for these compliance acronyms, and most of the major cloud providers will have them, but then there's the above and beyond. What is specific to healthcare? The gold standard, like high trust. Does the cloud provider have a high trust certification? Because then they're thinking about this cloud delivery specifically with the requirements that harmonize the best practices of healthcare security and compliance. And what do they do to harden and build the cloud all the way from end user access, let's say through VPN, to, as Dez described, the encryption of data in motion at rest? Are they adding monitoring and intrusion detection? Are they able then, moving to the management side, able to provide ongoing patching of the operating system, things like that, so that they reduce the risk of vulnerability? Those are the types of thoughts that need to go into working with the cloud. It does take humans to manage the cloud, and are they expert or certified in that particular cloud environment? Do they have some sort of a way to give you a dashboard? How do you know that the build that they did that was originally compliant has not drifted from compliance? And then are they able to back this up with legal agreements, business associate agreements with indemnification and insurance that is right for your stewarding your very important health information? Are they able to have a very aggressive breach notification window where they can tell you if there's an issue very quickly? Will they stand up to all of that contractually? Those are some of the pieces that you'd want to fold in to the design, selection, build, and management of the cloud.
Yeah, if I could just jump in quickly there to follow Scott up. I think one of the other things that I'm sure Scott will agree with is that by going to the cloud, you almost relinquish that control in a way and make an assumption that there's controls there. Most cloud providers now will give you certificates of compliance as well. So depending on, particularly more importantly around health and what hospitals are being tasked with regard to saving lives, there are a number of core fundamental requirements that the data center providers have to meet, and that's no different in cloud. So often it's a case of asking them to provide that evidence, provide a certificate of compliance to some particular thing, or provide access to a third party who has done that monitoring and reporting for them.
Yeah, good point. And I know it'll be hard to contain yourself, pun intended, on the topic of containers. But this stuff really is groundbreaking and fundamentally changing how we look at hardware resources. You know, we're talking about virtualization, but not just of applications, right, of actual hardware. There's a lot of cool stuff. Very quickly, talk about microservices and containers.
Yeah, I'm going to keep a very high level on this because it's a topic we could just spend a whole day on. We've been through this journey of physical servers, virtual servers. We're now in this concept of sort of containers. And containers are a concept that have been around for a long time. You know, in the mainframe days, we might have considered them as something we called LPARs, logical partitions. We would partition off a piece of the mainframe and just throw a batch at it, and the batch job would run specifically in that piece of resource that we described. In periods recently, we would have in BSD Unix and in Solaris Unix, we might have containers talked about as zones or jails. In the cloud, we've taken that to the nth degree now, and that is that cloud providers can have services sitting there ready for our consumption instantly on demand. And what this allows us to do is we now talk about it as serverless computing. And the reality is there's servers sitting there waiting for the work, but we don't have to think about them. We now consume them as services. And so some of those fundamental things like storage and network and compute and even security, when we think about them as services, and we have frameworks like Lambda and Zeta, particularly Lambda, that's been around since the 70s, believe it or not. It's just that we've modified it for the cloud. We can now consume things as services. And the best way to think about that is that if you click on a URL, at the end of that URL is a whole stack of infrastructure that actually receives the request for that URL, recognizes whether it needs SSL, connects to the application server, connects to the database server, connects to disks and databases and storage, and connects to routers and switches and servers with firewall policies. When you click on that URL, you don't really think about what happens to it. You're just clicking on a service. So apply that to your architectural framework and your workload models from a design point of view, and it changes the way you think about how you're going to build your infrastructure. Now, it's a really heady topic for CIOs to get their heads around, particularly now that a lot of the pedigrees of CIOs are coming from MBAs rather than technical backgrounds. But it's exciting because it means that we can completely change the way we think about consuming stuff, infrastructure. And so I'll probably just leave it at that because I think it's a very deep topic, but it's a thing that's coming through now by default. We aren't necessarily thinking about how we may consume microservices and Docker and Kubernetes and Mesos and other platforms like that. They're actually being built into the tools by default. And you know, over a very short period of time, we're going to see that transition to development to consume microservices in cloud environments, in bespoke-built clouds or generic clouds by default. It isn't going to be a case that I want to use it. It's built there by default. You get no choice. And this is an exciting thing because it dramatically reduces the time to develop things and dramatically reduces the cost to run them.
Yep, Scott, some comments from you?
Absolutely, yes. So, you know, kind of coming back to the very top of the conversations, what is the clinical and business value? You know, what are the pressures? Well, we see the trends towards massive demands on us as health IT professionals. We have to move faster. We've got to deliver services better. Those services are now used in patient care. They involve collaboration, so they need to be more stable and easier to update. Well, that's what microservices and containers provide for. So it's a technical trend that completely dovetails with the clinical and business issues that we're facing today. That's great. That's all well and good. However, because this technology is relatively recent, we do have this challenge of compliance. These services are not necessarily out-of-the-box compliant for healthcare. They are not necessarily covered by a business associate agreement. So they don't necessarily provide encryption at rest and in transit. So you've got to talk with somebody. How do we have a secure encrypted communication between one container and another? And you've got to ask those hard questions and make sure that you're, again, using these great tools of services and microservices and containers, but you're using them in a way that is respectful of this very precious health data that you are stewarding.
Okay, good. And I know we already talked about collaboration a little bit, so I'll just push this slide so folks can see it real quick. And let's jump to the final slide so we can get some content around this, the IoT. So, Dez, quickly from you, what do you think about the IoT? It's obviously a big deal in every industry. What about healthcare?
Yeah, in fact, I think when I think about the two or three areas where IoT are going to transform our worlds, healthcare is at the absolute top. There's some exciting things like smart cities, smart infrastructure, logistics in planes, trains, automobiles, airplanes have certainly made good use of IoT. When you look at the Dreamliner 787 with 6,000 sensors in the wings and the body of the airplane and generating half a terabyte of data per flight. But in health, the scope and the breadth and the depth of where the concept of Internet of Things can completely transform this industry are so exciting. But as Scott regularly reminds me here, it also needs to be managed. It also needs to be corralled in a way in a positive sense, not constrained, but corralled and guided and managed. So key topics are like dumb sensors that exist are now being connected to things that turn into smart sensors. So I might have something that's monitoring, say, the temperature in my floor or the room or the area, and now taking that sensor where I might have to physically walk up and spin the dial to change that temperature. Smart sensors are being put in place, or those dumb sensors are being modified so that I can do that remotely and I can do it wholesale, and I can also put some intelligence behind it. And it can take into account things like outside weather and wind effects on the building and then reflect that back in how much heat or cooling has to be applied to get the room to a certain area. And I can do it on zone by zone. We've got this concept where we were talking about machine to machine, M2M, as we've heard it in IoT, devices talking devices. We're now seeing essentially what we're referring to as human to machine. And that is that a sensor is strapped to me that I might, as a famous Monty Python joke about where the guy walks in the room and says, I see you've got the machine which goes bing. We've got little things on little stands and wheels, and we carry them around, and every time your pulse goes, it goes beep, beep. If we sort of get rid of the beep, beep bit that drives people mad and we put that into an Internet of Things sensor and we can monitor that in real time, we now have human to machine. We've got something that's interacting with me in some form, my physical movement, my logical environment around me, my virtual world, stuff that's happening inside of me, linking back to machines and reporting in real time so that I don't have to have someone in the room hearing the beep to see whether I've got a pulse or not. There's a system monitoring it in real time and alerting people if it stops going beep in a virtual sense. We have that transforming into cognitive computing. So, we've seen a whole range of smart things come in here. Now we're seeing, even smartphones have things like Siri and Watson attached to them, so I can sort of say, Siri, what's the latest score for the Cubs game? And it'll talk right back to me. That's moving into the sorts of things that folk like IBM with their Watson platform are doing now, and we've heard about them sort of win TV shows. But that cognitive computing is coming into the IoT. So we've got devices that are going from being dumb to smart sensors. We've got the human to machine transition where that stuff's being built into some of the things we talked about earlier. And now we're seeing cognitive come into the IoT where the devices are linked to smart things, and smart things can make decisions on what's coming out of those. And where CIOs are really having to think long and hard about this is what it means to their networks, and particularly around the topic of what we call industrial internet. And that is that we've taken the internet for consumer-grade stuff, and we're now putting industrial-grade stuff on it. Sensors are being connected to the internet at large. I mean, smartphones. Think about the transition of smartphones from carrier networks to Wi-Fi, free Wi-Fi, and internet connectivity. The IoT is it's an explosion. It's an explosion in capability. It's an explosion in the types of things we can do and the benefits to humans, and particularly around health and hospitals. There's also an explosion in challenges, as Scott will probably talk about, with controls and security and governance that needs to be managed. So it's very exciting on one side, but on the other side, it's also a positively scary idea, and that is that it's a runaway freight train. It could be a problem. You've got to harness it. And I think we've got technologies like blockchain that will come along and help us in many ways with that.
Yeah, Scott, some comments from you on IoT. Obviously, it's a huge issue, but where do you see the low-hanging fruit for hospital CIOs?
Yeah, I do. See, I'll use a specific example. I think it's often good to just look at it that way. So we are working with a cardiac device manufacturer who is working with some hospitals, and they're, again, trying to tackle this issue of decreasing cost and increasing quality of care, and they're partnering in order to do that. So post-acute, after the device is implanted, they are taking telemetry from the cardiac device, but then also from other things on the internet, like a scale and a blood pressure device, and then feeding that into a big data environment, and then having a nurse care manager evaluate that information to determine that person's fine, or maybe give them a phone call, tell them to cut that back on their salt, or tell them that, look, on your next visit, ask your physician about this, or, you're in a bad place, get into the ED right away. So this is really a great combination of the cloud powering it, IoT feeds into a big data environment, which is reducing hospital readmissions and bad outcomes. And I think we're going to see more and more of that. Again, all with the caveat that we've got to be designing, building, and managing these things that they will be secure. And that's a challenge, but it's one that I think that we as an industry are up for.
Well, that's a great way to end the show here today, folks. Big thank you to the folks at ClearDATA and, of course, to Dez Blanchfield from calling in from the other side of the planet. He is antipodal. I learned that word about 6 months ago when he started working with us. So antipodal, on the other side of the planet. We will archive this webcast. We do for all these events. You can go back to HealthDataManagement.com, usually by the next day. And if you were unable to download the slides, feel free to email yours truly, dmradio@sourcemedia.com. I'll be sure to get them to you. And with that, we're going to bid you farewell, folks. Thanks for your time and attention. We'll talk to you next time. Take care. Bye-bye.